Hi, here in Meenakshi. Welcome you all to my channel, Matrices. Today we are going to see matrices and some types of matrices. Outline, definition of matrix with example, types of matrices with example, and properties of matrices. What is the objectives? On completing this section, you will be able to know the definition and the meaning of a matrix and also know the dimension of a matrix and types of matrices with example. Then what is called a matrix? A matrix is a rectangular arrangement of rows and columns. Here, according to our notation, any m cross n matrix can be taken as A equal to A11, 1 to 1n, A21, 2 to 2n, and AM1, M2, M1. These are the elements or the entries of the matrix A. All Aj's are real numbers, then they are called the element. These are called the elements of the matrix. The above matrix, there are m rows and n columns. This matrix is called a m cross n matrix or a rectangular matrix of order m cross n. If m equal to n, then the matrix is called a square matrix of order n. These are some examples of matrix. This is a 2 cross 3 matrix, 2 rows, 3 columns, 1, 2, 2 rows, 1, 2, 3, 3 columns. This is a 3 cross 2 matrix, 3 rows, 2 columns, 1, 2, 3, 3 rows, 1, 2, 2 columns. This is a 1 cross 4 matrix. This is also 2 cross 1 matrix. This is a 3 cross 3 matrix, 1, 2, 3, 3 rows and 3 columns. Then properties of the matrices. If A and B are the matrices of the same order, then A plus B equal to B plus A. This is same order means the rows and columns are equal, which is A plus B equal to B plus A, which is a commutative law for addition. If A, B and C are the matrices of the same order, A plus B plus C equal to A plus B plus C, which is the associative law for addition. If A and B are the matrices of the same order and K is a scalar, then K into A plus B equal to Ka plus Kb. Then A plus 0 equal to A plus the 0 matrix. We want to add any number with 0, we get the number. Like that, here the matrix A with the 0 matrix, we can get A. Then A plus minus equal to 0, 1 plus minus 1 equal to 0. A plus B equal to A plus C implies we can cancel A and A, we get B equal to C. B plus A equal to C plus A, we get B equal to C. Then we multiply any number with 0, the result is 0. Like that, here A into 0 equal to 0. Then AB the whole inverse equal to B inverse into A inverse. These are some properties of matrices. Then types of matrices with example. The first matrix is equal matrix. What is equal matrix? Two matrices A and B are said to be equal if they are the same order, and then we can equate the corresponding elements. The corresponding elements are equal, then we can write A equal to B. Here A and B are the two matrices of the same order, means this is a 2 cross 2 matrices, this is also a 2 cross 2 matrices. Okay, then we can directly equate the elements or the entries of the matrices. Then A equal to 2, B equal to 3, C equal to 4, and D equal to 7. Then square matrix. Square matrix contains, we already know, in a square matrix, both rows and columns are equal. M equal to N. If the number of rows and columns are equal, then the matrix is called a square matrix. Capital A equal to Aij, M cross N is a square matrix, or M equal to N. Here A equal to, this is a 3 cross 3 matrix. Okay, here the rows and columns are equal, M equal to N. These are the another examples of a square matrix. This is a 2 by 2 matrix. This is a 3 by 3 matrix. Then zero or null matrix. Zero or null means nothing. If all the elements are 0, then the matrix is called a null matrix or 0 matrix. A null matrix may be a square matrix or a rectangular matrix. Square matrix means both rows and columns are equal. It may be a null matrix, may be a square matrix or a rectangular matrix. Capital A equal to Aij, M cross N, where Aij equal to 0. Here, this is the example. This is a rectangular null matrix. This is a square null matrix. The row matrix. Row matrix, a matrix contains only row. Only one row is called a row matrix. Capital A equal to A1, A2, A3, extra A is the row matrix of A equal to Aij 1 cross n. These are some examples. Only one row, 1, 2, 3, 4 columns. Row matrix of order 1 cross 4, 1 cross 4. This is one row, 1, 2, 3, 1 cross 3. As usual, column matrix is only one column. Okay, a matrix that contains of, similarly, a matrix that contains of only one column, m cross 1, is called a column matrix. Here B equal to B1, B2, B3, extra Bn, A equal to Aij, m cross 1. These are some examples of column matrix. Here column 1, 2, 3, 3 rows, 1 columns. Here 1, 2, 2 rows, 1 columns. Then unit matrix. What is unit matrix? Unit means 1. A square matrix in which all the leading diagonal elements are unit and other elements are 0 is called a unit matrix. It is noted by I. This is the main diagonal or leading diagonal. This is upper diagonal elements. These are lower diagonal elements. Okay. In a square matrix, a unit matrix is a square matrix. Rows and columns are equal. This is 3 by 3. This is 2 by 2. In main diagonal only unit, only in a square matrix in which all the leading diagonal elements are unit. It is the leading diagonal, all the leading diagonal elements unit. It is noted by I. Diagonal matrix. All the elements are entries other than the main diagonals are 0. Or this is the main diagonal. Okay, diagonal element. All the entries other than the main diagonals are 0. This is the main diagonal. Here, other than the main diagonal, upper diagonal, lower diagonal, this is a 0. It's called a diagonal matrix. Then scalar matrix. A diagonal matrix in which all the diagonal elements are equal is called a scalar matrix. In a diagonal matrix, all the diagonal elements are equal. But in a diagonal matrix, diagonal contains element, but these elements are not equal. Here, all the elements are equal, which is called a scalar matrix. We can say that the scalar matrix is a diagonal matrix in which the diagonal contains the same element. A well-known example of the scalar matrix is the identity matrix in which the diagonal elements contain the same value. Okay. Then symmetric matrix. Symmetric. A square matrix capital A equal to Aij is called a symmetric matrix if it satisfies the condition if Aij equal to Aji for all I and j. These are Aijs. These are the Aijs or the entries of the elements. A symmetric matrix remains unchanged if rows and columns are interchanged. What is the meaning? When we try to interchange rows into columns and columns into rows into columns, columns into row. When we try to interchange rows into columns or columns into rows, the matrix remains unchanged. Here see AHJ is row 1, HBF row 2, GFC row 3. When we interchange AHG, HBF, GFC. This is the symmetric matrix. Then skew symmetric matrix. A square matrix capital A equal to Aij is said to be skew symmetric. It satisfies the condition Aij equal to minus Aji for all I and j. We know that Aii equal to 0. What is Aii? A11, A22, A33. All the main diagonal elements are 0. Main diagonal elements are 0. The diagonal elements of a skew symmetric matrix are equal to 0. The Aii equal to 0. Then Aij. This is A11, 12, 13. Then A21, 22, 23, 31, 32, 33. This is Aij, A12, A21 are opposite side. Okay. Like that, A13, A31 are opposite side. A23, A32 are opposite side. This is all the skew symmetric matrix. And triangular matrix. A square matrix A is said to be triangular if it upper triangular matrix or a lower triangular matrix. What is upper triangular matrix? A square matrix capital A equal to Aij is said to be an upper triangular matrix if Aij equal to 0 when I greater than j. In other words, A square matrix is upper triangular matrix if all its entries below the main diagonals are 0. Below the main diagonal. These are the examples of upper diagonal. This is the below. Only it included the main diagonal and upper diagonal. Only the lower diagonal is 0. Then lower triangular matrix, a square matrix, capital A equal to Aij is said to be an lower triangular matrix if Aij equal to 0 satisfies the condition I less than j. In other words, a square matrix in lower triangular if all the entries above the main diagonals are 0. Here, this is the main diagonal are included or the leading diagonal included. Then all the lower diagonal have the elements. Here only upper triangular diagonal is 0. Classify the following matrices or some examples or upper or lower triangular. This is lower diagonal 1 is 0, upper triangular matrix. This is upper triangular 0, lower triangular matrix. Here lower triangular 0, therefore this is an upper triangular matrix. Here only diagonal element contains both lower and as well as upper triangular matrix. Then what is singleton matrix? Single means 1. Here m equal to n equal to 1. If in a matrix there is only one element, a matrix contains only one element is called a singleton matrix. Single means ones. These are the examples of 1, 8, 3, and 9. Okay. Then remark. It is seen that every scalar matrix is a diagonal matrix, whereas diagonal matrix need not be a scalar matrix. Every unit matrix is a scalar matrix, whereas a scalar matrix is not be a unit matrix. Keep watching my channel. Keep share and subscribe my channel. Thank you so much.